Hi, we've got a new project. This is an asteroid tracker. What it does, it tracks asteroids that are passing close to our planet. So I put a screensaver so that nothing happens after few seconds that you don't touch the button. And when you press the button, so now we have an asteroid. Let's get closer. Okay, so this is an asteroid 2021 CT1, I think it's called. Velocity 31,000 and whatever, 31,000 with few decimal. Distance 225,000 kilometers from us. So that means that it's passing between us and the Earth, between the Moon and the Earth. Okay, so let's try another one. Every time you press a button, you flip through. This one is passing 100,000 kilometers behind the Moon. As you can see, the distance is 569,000 kilometers, and the velocity is about 33,000 kilometers an hour. And the name is 2023 Neo. Okay, so there is quite a lot, and you get them from NASA using the NASA API, which will help you to collect the data and parse it with the Arduino library. This is Asteroid 2000 LF3. Velocity 52,000 kilometers an hour and a distance 724,000 kilometers. Now, if you think of the Moon, most of the time it's about 400. The distance from the Earth is about 480,000 kilometers. This is traveling right between behind the Moon, so it's quite far away from us. Let's have a look at this one. It's Asteroid 2019, White 83, velocity 21,480 kilometers an hour. It's quite slow compared to some asteroids that are traveling at 50,000-60,000 kilometers an hour. And the distance is 189,000 kilometers. That is between the Earth and the Moon. So this is a very close object, and I think they call it Earth close asteroid, something like that. Okay, so let's have a look if there is more. Yeah, you can add. It'll read right through because it doesn't waste memory. Sorry. This is Asteroid 2023 Neo, a velocity 33,000 kilometers, a distance 569,000 kilometers. I will pass through. Okay, and obviously I've used a press button. If you don't touch it for a few minutes, seconds, it'll go, it's got a screensaver, because you can't leave the imaging too long, otherwise it will burn the imaging on the screen. And I've got on the button, press button is on pin 4, and the OLED it's an I2C, and it's on pin 7 of the ESP32-C3, and it's pin 7, it's the SDA, and pin 6 it's SEL. All right, and this is a NASA website. All right, it's a NASA API. So you type NASA API, and here it's the URL, and then you can get your own. It's free. You get your own API key, and you can program anything. You can do anything. You want to search satellite. You want to look at the map of Mars and so on, and that is the API key. These are the codes of which I will publish them on the channel. Well, obviously I made a secret file, but you can just unquote this one. You unquote constant. You unquote SSID, which is your network's name, your password, and when you get the NASA API, you put it here, okay? Your API key. And this secrets, it's the folder here that I created by add a tab. So what you do, you don't need to include it, you double quote it, because you don't need it if you just use this system. Otherwise you can go into secrets and make your own secrets file with your own credence. Okay, so here's all the other codes that, as I said, I will publish. And here's the URL, which it's you can test it and see the data that you want to change. But I just prefer like this. And I add, obviously, what I need is a velocity and the missed distance and the asteroid pushback, and this is all the codes. Okay, so remember, this is the the NASA API keys where you get them. As I said, it's free. And you see now, because we waited a bit, the screensaver kick in, and it saves your OLED screen, so you don't have to worry about switching it on and off. You don't want to burn it, so you don't want the data. You can have it without the button, so that it flips through pages by itself automatically. But then if you want to pause and you want to read, like in this case, this Asteroid 2012 HG2 velocity, this is very slow, 10,000 kilometers an hour. It's almost what do you call it, an ultrasound, not ultrasound, a Mach 11 or Mach 10 missiles. The speed of a missile is about 10,000 kilometers an hour. And this is the distance, 327 kilometers. So this is almost close to hit the moon, because the moon is sometimes 300, between 380 and 480,000 kilometers from the Earth. Okay, so here we got this 21, we passed this one already. This one is 2000 LF3, velocity is 52,000 kilometers an hour. Distance from the Earth will be 724,000 kilometers, and so on. Okay, so it's actually a good exercise for school. But in any case, guys, have a good day. I hope you like it.